In this video, we're going to take a look at how we could find a polynomial function in factored form from some given information. And I want the video to cover problems of two types. One is where we've been given information in this form, and it would be problems like I'm looking at problems out of section 5.1 of our book, where we've been given the zeros of the function and a particular point that it goes through. And then we could be given that same kind of information in a different problem where it's not given and stated here like it is where it's in a list, but that we have it from a graph. And that would be a problem like, say, number 77, where we're still being given the zeros, and we're also being given a point that the function goes through. And our job in both cases, whether we're given it that information as a list, like we are here, where we need to go ahead and find a function that goes through these zeros and this particular point, or we're given those zeros and a point as a graph. Our job is to go ahead and find the function that would fit that information. So I think I'll just go ahead and work through 77, but realizing that if you were given that the zeros were this, and this point was also a solution of your function, it would be the same kind of problem. Okay, so here we go. We'll go ahead and draw some information here. Let's see what we can find. Well, it looks like from this we could create our own list, kind of like that other problem I was showing you. And on this problem, we could say that the zeros of this function are, let's see here, this would be negative 1, 2, 3, 4. It would be negative 1, and also at 3. So this function has 3 zeros. One of them has a multiplicity of 2. Do you see whenever it touches or bounces like this, we know that it has a multiplicity of 2. So this is really a fourth degree polynomial function because it has 4 zeros to it, right? It has to be at least a fourth degree. And so we got a situation 2 where we also go through this point right here, which is a 1, negative 8. Okay, so let's go ahead and see if we can take that information and put together a function. So we know this, and by the way, it did mention here smallest degree possible, so we're going to go for a fourth degree polynomial. I mean, it could be more than that, but we know it has to be at least a fourth degree to have, this have a multiplicity of 2, and this has a multiplicity of 1 and 1, so that's a total of 4 zeros there, right? Okay, so we're going to go ahead and say this, that we know our function would take on the factored form of maybe some coefficient here, a in front, and then we would have, in order to get a 0 of negative 4, it would have to be coming from a factor of x plus 4. Imagine setting this to 0, or y coordinate to 0, as if we were going to go ahead and solve for the zeros or the x-intercepts, that if we had a factor of x plus 4 equals 0, then x would be negative 4 like it is right here. So you always reverse the sign in the factor when you compare it to the actual 0 itself. Okay, so the next one would be x plus 1. And that would go ahead and give you a factor, a 0 of negative 1. And then we said that actually, let's see here, that factor is the one that has a multiplicity of 2. So we're going to square this, because that would be x plus 1 and another x plus 1. It would give us actually a 0 here, 2 zeros that are negative 1, right? And then we also had the 3. That would give us a factor of x minus 3, producing that 0 at 3. Well, the problem is we don't know exactly what this value is. So what we're going to do is we're going to substitute 1 in for x and negative 8 in for f of x and solve for that. So we would have this, negative 8 is equal to a times x, oops, actually we're going to put 1 in for x, and we'll put 1 in for x right here, and 1 in for x again. Okay, so we're going to solve that for a, and we would get negative 8 is equal to a times 5, and this would be 2 squared right here. And this is 1 minus 3 is negative 2. And I would get negative 8 is equal to a times 5 times 4 times negative 2. Well, 5 times 4 is 20. And I'm saying 4 because 2 squared is 4. 5 times 4 is 20. And 20 times negative 2 is negative 40. And now I'm going to divide both sides by negative 40. And it turns out that this would reduce to 1 over 5. And now that means our coefficient of our polynomial function is going to be 1/5. And the final function that resulted from the given information of these zeros coming from the graph and going through this point is 1/5 times x plus 4 times x plus 1 squared times x minus 3. And these factors, of course, could be in any order, but that would be the answer. And this would then, like I said earlier, this would fit problems like number 77 where you've been given a graph, and problems like number 51 where you've been given this information without any graph, but they gave you the information directly.